today, also known as box plots. I feel like it's pretty obvious how we could just make the jump to box plots. It's kind of faster to say. So the thing about box and whisker plots is that they use 5 elements to sort and describe data. Okay. We're going to start with some of the ones that we already know. So we're going to jump around a little bit. So you got to pay attention to stay with me. So first of all, the upper extreme is up here. Okay, the other name for that is the maximum, which we've already talked about. We use the max and the min both for the range. Okay, this is just the largest number in the data set. Okay, so it makes sense that it's up here at the top.
Yeah.
Okay. If the box plot was sideways, it would be over on the right.
Yep.
Okay. Now we're going to jump to the bottom. Okay, the little dot at the end of the bottom whisker, that is our lower extreme or minimum. Okay, this is the smallest number in the data set. Okay, so in the very middle of our data is our median. Okay, that's the same as before. So the median is the little line that's inside the box. Okay, that another name for it is the center. Okay, it's also known as quartile 2, Q2. Okay, we know it's the middle number in a data set. We know that half of our data is above this number, and then a half of our data is below. In addition to writing half, I'd like you to please write 50%. As long as you have it on one, that's fine. Everyone knows that 50% is half, right?
Yeah.
Okay.
50% of 200 is 100.
Okay, so already we've got some vocab that we know. So what we're adding today are the upper and lower quartiles. So the upper quartile is between the max and the center. Its other name is Q3. So you guys know the median, how it splits our data in half?
Yeah.
50% above, 50% below. Okay. Quartile 3, or the upper quartile, is the middle of the top half of the data. Okay. Last one. The lower quartile, or quartile 1, this is the middle of the bottom half of our data. I guess what I meant to do was draw some arrows, but I failed to do that, so I will do it now. Will you do this with me and draw some arrows?
Okay.
Thank you. I didn't even put Q1 on here. Okay, so it goes minimum, quartile 1, quartile 2, quartile 3, maximum. Okay, 1, 2, 3, bada bing, bada boom. Okay, so we said that half of the data was above the median, right? So from here to here, this is 1/2 of our data. Okay, and then half of the data is below the median. So that's half also. It looks bigger, but it's the same amount of data. So, guys, remember that the upper quartile and the lower quartile chop the top and bottom halves in half again. So, right here, this is 1/4. This will be 1/4. This will be 1/4 of our data. And this is 1/4 of our data. This up here looks pretty gross, so I'm going to try that again. 1/4. So 1/4 of our data is here, 1/4 here, 1/4 here, 1/4 here. Everybody happy with that? Okay. All right. Anyone want to guess what this asterisk is? Outlier. An outlier is marked by an asterisk. Okay, this is important, and it's kind of weird to think about, but our quartiles do not actually have to be in the data set. We're going to write it, and then we're going to talk about why. Do you remember when we had an even number in our data set and we had to find the median and we had to go like between two numbers?
Yeah.
Okay. So our median doesn't actually have to be in our data set. It can be between elements in our set, right? Yeah. And if quartile 3 and quartile 1 are the middle of the top and the middle of the bottom, can't they also be between values? Yeah, they can. So the quartiles do not actually have to be in the data set. Okay, they're like dividers of the data, like a fence. So you can either be like on one side of the fence, the other side, or sit on the fence, but you can't be in the fence. Does that make sense? Okay. So here we go. So we have our 5 elements that are like the fences, okay, or the dividers. And those 5 dividers divide our box and whisker plots into 4 segments. Okay, each segment represents 25% of the data. So on the up and down big diagram, we just did 1/4, 1/4, 1/4, 1/4, right? Okay, here we're going to say, isn't 1/4 25%? Okay, so I've got 25% right here, 25% in here, 25% in there, and 25% over here. Okay, these segments are separated by the quartiles. Okay, a quartile is a single value, not a range of numbers. So we can say that a score or an element of data lies above, on, or sorry, not on, at, or below a quartile. Above a quartile, at a quartile, or below a quartile. You cannot have a data point in a quartile. You can't be in a fence, right?
Yeah, sure.
Okay, yeah. Yeah. Okay. We are going to find the spread of the box plot at the right. Can anybody remember what spread means? What's the synonym for spread?
Like, it's the most plot. Like,
Separate.
No.
So
You're thinking of a
Slide?
different use for spread.
I'm thinking of like jelly,
I know, okay, I'm not thinking of jelly.
like disease
Or
what?
cheese.
No, we're not talking about the spread of disease. Okay, guys, think about your maximum and minimum values.
Range.
The range, yeah.
Yeah.
See, it was in there somewhere. Okay, so another name for the spread is range. Jelly. You put jelly on your test and see what happens.
Okay, my bad.
You'll be sorry.
Will I get a good grade?
No. But I feel like you know that. Okay, so if I want to find the range, I take my max minus my min. Okay, so that would be 100 minus 75, which is 25.
You have to put the, can we just put 25 or just put the math? Like on our homework.
What?
Like, do we have to write 100 minus 75 or can we just write 25 and we know it's 25?
I want you to write it like this on the notes so that you know where the 25 came from. If you can do it in your head or on a calculator and are so confident that you don't need the work points, you do you. I would suggest writing it so that if you get something wrong, you can at least get some work partial credit. Okay, now we have to find the interquartile range for the box plot. All right, who knows what the prefix inter means? Inside, okay, good. And it's like inside or like between, right? You're warm. Okay, so inter means between, write that down. Oops. Okay, quartiles are obviously quartiles, right? Interquartiles. So the quartiles that we want to go between are Q3 and Q1. Yeah, Q3, right here, and Q1. I didn't put 1/3, it's an and. Oh my gosh. I'll just write out the word and.
Oh, I thought that was it. I mean,
It's fine. You're probably not the only one who thought it looked weird and wrote it strange. So I'm glad that we got to clear it up.
I see that a lot and I get kind of confused.
Okay, well now you know what it means. So when I think of this and I see interquartile range or IQR, what I think of it is like box range. So it's just the big end of the box minus the little end of the box. Right? So 95 minus 80, which is 15. Okay, so the range and the IQR, interquartile range, are measures of spread, like how far the data is apart. We can have two very different sets of data that have very different mean, median, and mode that have the exact same range. We saw that in our measures of central tendency data, right? Or notes is what I'm trying to say. Okay, let's look at the next page. Okay, these examples are all about shape. All right, so what we're going to try to do is fit 5 dots in each of the sections defined by the quartiles and the max and the min. Because remember that each of those sections is 25% of the data. So they should have the exact same amount of data in each of the sections, right? Okay, thank you. So I've got 1, 2, 3, 4, 5 dots. 1, 2, 3, 4, 5 in that section. 1, 2, 3, 4, 5 in that section. And 1, 2, 3, 4, 5 in that part. So the reason that I want you to put the dots on here is because it's easier to visualize the elements of the data set when it's represented by dots. Visually, when you look at this, it's a little bit misrepresentative because it looks like this section is huge, doesn't it?
Yeah.
Okay, so it's huge the way Wyoming is huge. Wyoming is a great big state, but do a lot of people actually live there? No, it's mostly like buffalo and like tumbleweeds, like woo, right? Okay. Over here, this looked tiny, right? But it's tiny the way New York is tiny. There's a whole lot of people in New York City, right? Okay, so like Wyoming, Buffalo. Nobody lives there. Okay? New York. We got data packed in really tight up here. Okay, so the closer our dividers are together, the more densely packed our data is, like little sardines. Does that make sense? So what I don't want you to do is think that this is the lump, because is that the lump? No, it is not the lump. Okay, the lump is here. This is our lump, and our tail goes this way. So keeping in mind that we have a lot of the same shapes that we learned the other day, what shape is this?
That's
Right.
skewed.
You're really close. Skewed left, because the tail is on the left. We're doing lots, but this is one of the things we're doing. Okay, let's go across. All right, go back to your 5 dots. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Yes, kind of even.
We're kind of going for that.
So, do you remember what this shape was called?
Perfect. Symmetrical.
Yeah, symmetrical.
Yep. Yes.
Okay. Does anybody remember the other names for it? Yeah, bell was one.
Bell. Yep.
Okay, then there's one kind of weird name that was kind of scientific sounding.
Mountain.
Normal. Good.
Not name.
Not mountain.
Also not name.
Okay, so what you might notice about this one is that the median is in the middle. Right?
Yeah.
So if we have the median and the mode and the mean all ending up in the middle together, then we have a symmetric distribution. Cool, cool, cool?
Mm-hmm.
All right, let's keep it moving to this one. All right, let's do some dots. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
Skewed right.
Okay, how did you get that? You're correct.
Because
First of all, where's the lump?
on the left.
Okay, the lump is on the left,
And not box it.
and then tail off to the right. So this is skewed right. Okay, bottom row. What about this one? Hello?
Hi. Hey.
What is this one?
That is skewed left.
Skewed left again. Good.
Oh yeah.
All right. What about the one, this one?
That's
Skewed right again. It's harder to see a bimodal on a box. Yeah. So bimodal and uniform are kind of weird ones. Those are, you're more likely to see that with like a box plot. For this in Algebra 1, these are the most important 3. Okay. Let's see if we can figure this out together. All right, we have comparative box plots representing GPAs for graduating classes for two different colleges, College 1 and College 2. So we're going to identify all of these things for each college and then answer some questions. All right, where is the center for College 1?
3.0.
3.0, good, right there.
3.0.
Yep. Okay, what about for College 2? Where is the center for College 2?
2.0.
Okay. All right, what about the range for College 1? Okay, we take the max and subtract the min. So that would be 4 minus 0.5, which is 3.5.
3.5 again.
It is?
Yeah.
Oh, because it's the same. Okay.
Is this like, are they doing GPAs or something, or what are they doing?
Yeah, this is GPAs.
Okay. Is it okay if I call my mom back?
Okay, is it an emergency?
I'm not sure.
Okay. I mean, do what you got to do. Okay. Lower quartile for College 1,
1.5.
1.5. What about for College 2? 1.0.
You have a 1.0, does that mean like your whole house?
I think it might be D's.
Oh, yeah.
Upper quartile,
3.5.
and for College 2,
3.0.
okay. Interquartile range, this is what I like to think of as the box range. So it would be the 3.5 minus the lower quartile, which is 1.5, which is what? 2. Okay, and then for the other one, it would be 3.0 minus, what is that, 1.0? Which is also 2. Okay, now, remember that when we said skewed right, we also could say that that was skewed up and that skewed left was skewed down. It's in case your box plots are oriented vertically like this, you know? Okay, so remembering that the quartiles are chopping our data into fourths, each worth 25%. Okay, where is our data lump? Okay, where's the lump? At the top or the bottom? Okay, we got a lump at the top, and then we got a tail coming down. So which way is this skewed?
Down.
You are correct. It is skewed left or down. Good. Okay, what about for College 2? Yeah, it's skewed up. The lump is kind of down here, and the tail goes the other way. Okay. Now we're going to do some questions to make sure we understand the implications of all of this. Okay, first one, which is B. You ready?
Yeah, I think I'm ready.
All right. It says, if you need to determine which college has higher GPAs, which measure is more useful, the interquartile range or the median? Okay, first of all, before we start yelling stuff out, which college actually has higher GPAs? Okay, perfect. So that was question D. So we'll just answer that one right now. College 1. Okay, now if I compare the IQRs between college 1 and college 2, is there anything about the value 2 and 2 that tells me that college 1 has higher GPAs? No. So 2 equals 2, so that is not helpful. The IQR does not tell me anything helpful. Does everybody understand that?
Yeah.
Okay, which college has the greater median? Which one has the higher median, which is the center? Okay, maybe we need to write that word down. Okay, the median is the center. Okay, so one of them has a center of 3.0, which is greater than a center of 2.0. Do you think it's any accident that the larger median corresponds to larger GPAs? No. Okay, so the one we want to pick is median. Does everybody understand why?
Yeah.
The IQRs were the same and they did not tell us anything. College 1 median was bigger than median for college 2, so it tells us that overall that data is higher. Cool? All right, so this one is very similar. You ready?
Yeah.
If you need to determine which college has higher GPAs, which measure is more useful, the spread or the shape? Good, because what is the spread? Spread is the range. And both of the ranges are the same. So the range for both is 3.5. So if they're both the same, can it tell you which one has higher GPAs?
No.
No.
They're the same.
They're the same. Not helpful. Okay, the shape, however, for the shape to tell you which one has higher GPAs, you kind of have to ignore the tail. And you have to look at where the lump is. Okay, this one has a high lump, right? This one has a low lump. So for college 1, the data is concentrated on the high end, right? And for college 2, it's concentrated in the low end. So there are more lower values. Does that make sense?
Yeah.
Okay, so it's the opposite of the tail. So for the shape, you're going to look for the lump. Guys, these have the same range. They have the same max and min. So what tells us where the data is located within those parameters is the shape. If our data is between 0.5 and 4 and concentrated high, then we're going to have higher data, right? Okay, that's what I'm saying. All right, true or false? Hold on. Half of the graduating class from College 1 had a GPA below 3.0. It's true, but it kind of looks like it might be false because this is so huge looking, right? It looks like it should be more than half, but it's not. That's actually true. Okay, what percent of the graduating class from College 2 had a GPA below 3.0? Yeah, 75%. Because this is 75. Oh, sorry guys, that's 25%. Fake news, fake news. This is 25%. This is 25%. And this is 25%. So it's 75 altogether. And that's the end.